Hello everyone from the Novedge team. Welcome to today's webinar, VR and 360 via real-time virtual production. Join us in the AFK TV studio in Munich for a hands-on session of live, real-time virtual production. Witness the creation of stereoscopic 360 virtual reality movies or live streams using the Shark 3D Live virtual production solution system. The webinar will also touch on differences to non-VR virtual productions. Topics included are setup, perspective and distances, chroma keying including shadowing, video integration, virtual elements, and animation. You are in for a great show. Presenting the webinar will be the team that includes both director and founder of AFK TV Munich, plus the engineers at Spinor that will perform all their magic. And you'll be able to see them soon, and they will introduce themselves. Just wait a few more seconds. In the meantime, I want to remind you what Novedge is all about. Novedge is one of the largest online stores for design software, and we offer a huge assortment of software solutions. So if you want to check it out, visit us at novedge.com, where you can also find the Shark 3D software system. And for more daily software news and limited time promotions, pay a visit to the Novedge blog and follow us on Facebook, Google+, and Twitter. Coming up next week, a webinar on designing context with Vectorworks 2017 camera match tool. Last but not least, today's webinar is free and will be recorded. So if you want to rewatch it, just head on over to the Novedge page on YouTube and Vimeo. And now, without further ado, I'm going to pass the screen to Volker in Munich. And voila. Hi, guys.
Hello, Barbara, and thank you, Novedge, and thank you for letting us doing the webinar tonight. Let me make a quick introduction of the team here. Next to me is Aline. Hello. Aline is the host of our show, but also the vice president of the German board for immersive media and virtual reality. Next to me is Thomas. Thomas is our VR evangelist. He is a former employee of Microsoft and is doing everything in the VR world here in Germany. Let me rotate the camera a little bit. Over here is our director, Toby. Toby. Hello. And Thomas is here on the camera, and you see our camera with the auto cue on it. And another pan. Moritz is down here. You see him? Hello, Moritz. He's doing the audio. And here is Peter. He is the virtual reality production manager, engineer. Yeah. And Volker. Volker is the head of Spinor and is the developer of Shark 3D. And over here is Eleni. She is also a virtual reality enthusiast. So let me turn the camera again back to Thomas. And because with Thomas and we did, let's say a real demo, because we are a group of people who are from different disciplines. Yeah, here are creative people, here are people from the technical side, and the last thing we did was something for the German Ministry of Economics last weekend. And why is this kind of software and this kind of people bringing together the right thing to do?
Yeah, actually, you know, as you mentioned, we recently used this VR production technology for creating VR video for some reverb productions. You know, traditionally we came from the field of classic 360-degree production, so using real camera rigs going out in the real world. And most of you know probably it's hard to create high-quality 360-degree video, especially when it should be stereoscopic, or you know, you have a lot of stitching issues. Very often the real world doesn't match your storytelling needs. And so when you switch over to the VR production technology, there are a lot of benefits. So the first is that it's much easier to create high-quality stereoscopic video and also put in even 3D sound effects, you know, because you create it virtually in the studio environment. So the second benefit is that you are much more flexible in your storytelling because you can create a virtual environment, you can mix it 3D objects with 2D video or picture footage, you know, so it's much easier to create an environment which allows you to tell the story you want to tell. And the third benefit is that since you're using a lot of 3D assets, you're maybe using in a VR application, so your VR video is much closer to the real-time components you need for your VR application. So it's really a great experience, and you know, watch the rest of the webcast to learn all the details how it's being done.
Okay, thank you, Thomas. And you just mentioned that the production is possible here in real time. And you see over here our Oculus setup, with Toby afterwards will direct a virtual reality shot and will show the position of our host Aline in the virtual world. So, but let's get back to Volker, who is the head of Shark 3D. And ask him what setup is necessary to what do we have here for your software?
Various parts are is the same as for classical virtual production. We have here our green screen area. Maybe you can turn a little bit around. And in this case now, since we are now producing, is our mic on? Yes, it's on. For a virtual reality video, so it's obviously not on classical 2D framing. So you combine still 2D footage in this particular case with the virtual world we are running in real time. In this case, we use a classical 2D camera. We have here, maybe you can also turn around here. I have already shown it before a little bit. And other options would also include, indeed, to use live footage from a 360 camera, which is also a possibility. It's just much simpler to use a 2D camera because existing equipment, no need for this complex stitching issues and that kind of things. Although usually if you would use a 360 camera, then you would of course also ensure that either everything is green screen around the camera or some more advanced masking. But since in many situations anyway, many parts are virtual and the real persons or real props are only in a particular region, 2D cameras are completely fine and makes it extremely simple to use this existing production equipment to create VR movies now. I think this is a main point regarding setup. So, in the feeding obviously is a real camera footage into the renderer software. For live compositing, as we can already see here, we have Aline here in the scene here integrated with chroma key. As you can see here, she is here in the green screen. So, as usual virtual production, it's a real world. Maybe Peter, you can show a little bit around here. As it's just a simple demo scene with some stuff in here. Okay. So one point is, as Thomas already mentioned, to do it in real time, using real-time virtual production, which is done in broadcasting, for example, for a long time now, and it's also used more and more for movie production. For VR production, it has the same advantages plus some additional advantages, like since in VR and stereoscopic 360 video, depth is a quite important aspect. It's even more important to check as early as possible whether everything is laid out correctly, the distances are correct, and so on, which we're going through. Should we go into details?
Could you just sum it up again? What is so special about Shark 3D?
So our focus is real time. Also to not do it offline in classical post-production, where it has mentioned disadvantages before, that you have often to fix or try to fix issues you had in the production itself afterwards, which are not possible anymore because you didn't see it early enough. So real-time has the advantage of doing it in, doing also an onset pre-visualization. So to check onset what is, whether everything is correct, and avoid significant parts of the post-production because you can create the final footage already on set if you want. And if you want, you can also afterwards render it again in Shark 3D if you want to, for example, change the setup, move objects, exchange videos or something like this.
Okay, great. So it's easy, and it's a very easy first step into the virtual reality production process.
Yeah, definitely. Especially when reusing existing equipment, it's a very simple step.
Okay, so let's start with the green screen and the chroma keying, which is probably one of the biggest issues here. Yeah, you see Aline in our small green screen. Yeah, hello. Hello. Over here we would also have a larger green screen, which is now painted white, but we also can do it green, so there would be much more movement possible. Today we do it here in this one. Yeah. So what are the issues with the chroma keying in your Shark 3D?
Yeah, also at the end, it's a standard real-time chroma keyer with a quite good quality. Yeah. So we have this, also this already, we pre-configured it, but with the standard features of selecting the chroma keyer color and do the different settings about how strong the keying is done. Yeah. Also maybe you can play a little bit around with the parameters here. Yeah. As in this case, this is not different from classical virtual production. It's the same technique used. Some differences obviously are that because the framing is not relevant, because we are really just placing, in this case, Aline into the virtual world, that obviously the person must be full screen, must be completely into the camera framing. Yeah, there's no headshot or something like this, which makes sense. Yeah, and also, which is also relevant for the chroma keying. Yeah, if she walks outside, it doesn't make sense anymore. Yeah. And related to this, for example, manage is currently not set up, but if you want to have shadows also transferred from the green screen into the virtual world, then also the shadows should not be cut off, for example. Yeah. Maybe you can play a little bit around with this shadowing transfer parameter here. Where do we have it here? This one here. Yeah. One up. This one here, Yeah. This here, exactly. Yeah, to get a little bit of her shadows here, if you go close to it here, something like this here. So maybe completely to the left or so. Let's see what happens. Yeah, there's a lot of parameters to tweak around. Okay, now we have a little bit too much. Okay, in this case, which is normally a good thing if the green screen is well lit, then you don't have shadows on it. On the other hand, if you want to have shadows, of course, then also the lighting of the green screen must be in such a way that you have darker areas. And usually it's a trade-off between having the dark green colors either interpreted as shadows on the green screen, or if some people have some also dark green clothing or something like this, and obviously you want to keep it not out in this particular case. But I think that is some basic parts of the chroma keyer thing. Yeah. Some other trick is which we also use, for example, in the production Thomas mentioned before, is that which can be quite useful, that you have different chroma keying settings for different areas of the live footage. Like in this case, we had some politician which had some green clothing, because in Bavarian some clothing is green things, well, correctly. No? And so we use basically that splitting, that the upper part was configured to use green, also does not key out the green, but on the lower part for the shadowing, dark green was interpreted as shadowing. And in this case here, Peter has opened the shader setup for this, that we have two chroma keying nodes, which are then linked together by this, what is this node? This domain node, where basically you can then define in the properties, maybe you can select this one of the domain nodes, at which coordinate location the upper or the lower part of the chroma key is used. So if you want, you can make as complex setup as you want. And in practice, obviously, you try to keep it as simple as possible. But it's a lot of possibilities how you set up, in this particular case, your shader for different setups. But there are nice tricks possible. But I think these are the most important things regarding chroma key, if you think about.
Okay, then let's switch over to the camera setup, which is necessary. So here we have just a regular FS7 from Sony set up on a tripod, and which is a regular setup, which many of you guys in front of the screens might have. which also would be possible, but there would be other options possible to install. For example, we could use a camera tracking system and we could install a motion control system. So, for example, the avatar you see next to Aline could be moved by some actors if you would have motion control and camera tracking active. Volker, what do you think? What is the best position for the camera to get the best result for your virtual reality?
This is now part where there's a differences between classical virtual production and virtual production for VR. As in classical virtual production, you have the camera framing. And this is also why camera tracking is usually quite important as long as you don't have only fixed cameras, as if you do it in real time at least, or of course you can also do the camera tracking post-production, but if you do it in real time you need to do it live. And for VR there is no framing in the resulting 360 video or stereoscopic 360 video, so the camera is only used to place some real person into the virtual environment, so you don't see what the camera framing is. So like here we can see on the screen, there is no particular camera framing. So one important thing is obviously that the person should be completely into the frame of the camera. As I mentioned before, no cutting off. Also because obviously if you walk out, then it's cut off, which makes no sense. In contrast to classical movies where it's common that people walk into or outside the frame. On the other hand, since the camera frame is not visible, tracking is not as important. Because if the viewer is rotating his head, for example, or rotating the camera view in YouTube or whatever, then it's only changing how the 360 video is watched, but it doesn't change the camera setup. On the other hand, camera tracking can be quite useful, for example, to avoid the restriction that currently Aline is not allowed to walk outside her small area in the green screen studio. But without using a 360 camera, but just using camera tracking, if the camera would follow her and we get the tracking information into the virtual, onto the virtual camera, then we could also walk freely around in the 3D world, still assuming we have a large enough screen. Without these restrictions, except of course still she cannot come as close as possible to the viewer of the 360 video, because then it also gets cut off. Exactly as she's showing here.
And what is the best distance? I've heard you made up some kind of formula. To
this is also issue in this case because it's the simplest possible setup. So we're not using any, for example, stereoscopic camera, which would be also one way to do. So in this case, the resulting 360 video is still completely stereoscopic, as having depth. But Aline is only represented as a classical 2D image there. So it has a lot of depth, assuming that the virtual world has depth. The 2D image obviously not. But the point is, depending on the distance, it makes no difference. And this is exactly why we have this great formula here. In practice, if Aline is about 3 meters away from the camera or far away, then there is no visible difference for the left and the right eye. Still, obviously, it's important how she is placed in the depth of the scene, but she doesn't look flat. If she comes much closer, she can start looking flat, based on this formula here. Which in this case, the typical setups are with an eye distance of, what was it, 65 millimeters, something like this or so. And a typical depth, so for a human being, 20 centimeters, whatever resolution, in this case a 4K virtual reality video, then the result would be about 3 meters distance works out fine without needing a stereoscopic camera, but still getting a real stereoscopic 360 video by the virtual rendering. This is one thing.
So when you start your virtual reality production and you key the person into the virtual world, where is the person then located? How do you say Aline is here and not like 10 meters on the right or on the left
that's exactly
side?
one thing we can demonstrate them very nicely. Also, the first rule of thumb is obviously that the position of the virtual camera should match the position of the real camera, which could be done via camera tracking. But in this case, since we don't have tracking, we just do it by hand. And we also do the setup we want. As in this exactly one point, which is very useful, do it in real time to get it right, especially also the depth position.
And that's the one big advantage of your software, right? So he can really now tell you and Aline what to do to make the shot in the virtual world.
Exactly, you know.
So
Let's just do this in this case. As obviously, unfortunately, you as a viewer of the webinar cannot see what now Toby is seeing, but genau. So
this always is a pretty big mindfuck because you actually think you are in the same spot as the host is, though the host can't see where he actually is, so you really have to direct him. And that is one of the biggest...
Yes, okay.
Okay, there's a setting now. Okay, now I can see it. And I might say this is the biggest challenge to direct the people who are actually in the green and are not seeing what the director actually is seeing. So, which would mean how can Aline interact now with the avatar, or maybe with the car, or maybe later with the kitty, which is over there. So now here you see the problem. I'm seeing what she is actually not seeing, so I have to direct her. And this is a complete new way of directing, just if you consider how to direct people in 2D TV. So what we can do is just now, we maybe want the car in the back of Aline, so can we move the car backwards, please?
Yeah, let's do this.
So, and this is really great because you have the possibility to do all those stuff live. Just imagine having a TV show, having a virtual set actually, where you can make the real host interact with, oh, I'm getting dizzy. But it's looking so real, so amazingly real. Now she could interact with the car, she could talk about the car, though we don't actually have the car. Does that make any sense? Because it's a bit confusing because I'm in the virtual reality at the moment and she is not. And now it looks like she actually would talk to somebody and would stand in front of them. So that's one of the biggest challenges, but also one of the great chances you have with this. Also another thing we experienced while working on this is the way how to address people who are watching, which is, in our opinion, something different than actually having somebody, oh, this is probably easy because, which is something else than addressing an usual live audience or maybe an audience in front of a television set. So this is what we're trying to experiment, trying to find out how can we, with virtual reality, create stories, how do we have to develop the storytelling, how do we make it possible that the host is in interaction with everything that actually is in the virtual set. Yeah, basically that's it.
And you can arrange it in real time, which is...
You can arrange it in real time, which is a real amazing thing. Just imagine maybe a football game where you make it possible that the two hosts are actually in real time in a game, and you can walk around the players which you created in VR.
Let's try it out. Maybe we move her to the left and make her a little bit taller also.
Or control the car. We can also this is a bit we didn't do before, but you can at your command you can move the car forward, for example, something like this.
Okay, yeah, let's move the car forward.
Yeah, drive it forward. Runtime mode 6.
So, and if you just imagine that the car would be something that actually comes in front of you, it does, and it's a bit scary. And the same thing is with people. So if the guy next to Aline just steps forward to me, and she's talking maybe about him, she's telling his story or what he's up to, maybe he's trying to strangle me, actually he looks like that. Now he's walking backwards because I scared him off, I think. And these are all those little funny things you can play around with and try to develop actually a new kind of storytelling which you haven't seen before and which wouldn't be possible in normal TV.
But to have this experience so real, all the sizes, all the proportions need to be in sync, right? So what are the main factors to
Also the camera setup obviously is important. Also to maybe quickly go through it. Maybe again also Peter can show a little bit the details. Also the first thing is as this part is similar to classical virtual production to align the coordinate system of the real world with the coordinate system of the virtual world. Ne? Also for example, now you could move you around a little bit. If you we can disable then have a second view here. If you disable the Oculus for a moment here. So we could define this setup here. Also where in this case where Aline is then placed as virtual element. Yeah. This is one part. So it's the same as for classical real-time virtual production or also for virtual studio in broadcasting. The next step is, so since we don't have camera tracking, we do it by hand. In this case, entering the height of the camera. So before we measured it out, do we still have our measuring stick here, for example? Yeah? But I think, what was it, 1.60 meters or something like this? Yeah? Which we put here into the position of the camera base position. Node of the scene hierarchy. Shouldn't have changed from before. The same is also, since we don't use tracking by hand, okay, what is the camera tilt was something like 11 degrees. So, but this is not any detailed difference now, because in this case we are not rotating the virtual camera, because the virtual camera is still recording the 360 scene with a standardized direction with a horizontal look. Yeah, also because we don't want the viewer to look down. If the viewer is watching the video looking horizontal, also the scenery should be horizontal. Yeah, but we have to rotate the video in rectangle where Aline is projected on down by this degree, in this case 11 degrees downwards. Yeah. And then also to make a perspective correct setup, the distance how we place the rectangle containing Aline into the virtual scene should be matched approximately the real distance, which is about, in this case, 3.5 meters. So if we set up all these numbers correctly, then she is correctly placed in the virtual scene. Yeah? Still a very simple setup, but quite effective. Yeah?
But if I want to have her closer to my eyes, is it also possible?
We cannot, of course, start faking around by, for example, moving her in the virtual world closer to the viewer than she is in reality. Yeah? Also, for example, in the elements node here, if we then, in this case, we do it via scaling, also to add some technical details. This base distance we have also entered as on scale, simply because if we move her closer or far away, she not only must change the distance in the virtual world, but also the scaling. So that basically from the framing perspective of a virtual camera, she remains the same size, because also for the 2D camera, she remains the same size. Yeah? Whereas if we really fake by moving her closer only in the virtual world, then we really have to change this distance, which is, if you scroll down here, go to the, in this case, what is it here, this one here factor here. For example, now, maybe can you go a little bit closer here that we see her movement. And now it would be, of course, best visible in the headset. But for example, if we here .5 or something like this, then she obviously moves closer. And now the perspective is not correct anymore technically, but it could make sense, especially since in a real setup, if we're using a classical 2D camera is here, there's a limitation how close you can go. Also I think the 3.5 meters is already the closest possible for this field of view, and it's already the biggest field of view possible. But in reality, if you want to, for example, have some dialogue with the viewer, it makes sense to be closer. What did you use for VROC, it was, I think, half the distance, something like this, if I remember correctly.
This looks like the attack of the 23-meter woman. So you can do also stereoscopic.
Also what we didn't talk about yet, in fact, so far we only watched the scene on the Oculus headset in this particular case. But now the goal, of course, is to make a movie production. So we render it out as a 60 video. So Peter, can you enable it? And there's a different. What Peter just changed is for each viewport can have different triggers which define what kind of rendering technique is used. In this particular case, for the file rendering trigger, we set it up in such ways that it is enabling also the C60 rendering, and in this case also the stereoscopic rendering. As you can see, this is a panorama view, as you can also in this case is a runtime camera with a panorama view, and this is then also what you render out. Also here it's only more for verification. But did we miss something fundamental, or should we go? Okay, we didn't do all the setup yet, but but maybe we can do it now. So now there would be different output options. Also we already had the situation with using the Oculus for live preview. Then one output option would be to put it out as SDI hardware signal and feed it into a classical studio hardware. One issue, of course, is which resolution. Also for a good quality virtual reality or 360 video, we need a high resolution because obviously the 60 degree requires more pixel. So in definitely our experience, you should definitely use 4K. In a monoscopic view, typical resolution is 4K by 2K. For stereoscopic view, it's 4K, twice 4K by 2K, so effectively 4K by 4K. If the studio equipment can handle this, record it, etc., and so, you have the most possibilities. On the other hand, if you don't have the studio equipment for this, you can just render it out directly in the software. This is basically the second option by rendering it into a file. Maybe you can make a short recording here. Select a name. Also, Peter set up the resolution of 4K by 4K, and now indeed is rendering out. Was a quite short time, but hopefully everybody saw it. And now here, this is the rendered out file directly in 4K by 4K. Maybe you can quickly go to the options and show that it's really a 4K video. It's a quite short video, so it's also here shown below here. The typical frame rate is also 25 FPS. Okay, but this is exactly also the point of doing it in real time, is that you can real time shoot in the virtual world, like shooting in the real world, but just in the virtual world, but getting the results immediately, basically. But these are the basic options. But the fourth option also would be to use it for live streaming. Also, for example, connect it to a YouTube live streaming or proprietary application supporting live streaming. For a live virtual reality or 360 video broadcast. In both cases, as making show, Peter, where is this, for example, this node for this live streaming? We didn't look it up before the show, so we have to search it now. I think you have a lot of nodes
here. So basically, what you can do now is you have a virtual world, you have a 360-degree video. You can put it together with your live chroma keyed person or with your different actors, which do not even have to be in the same room or in the same location, and put them all together in a virtual environment, in a virtual world, and stream it out live to the world, and this all in 3D and in a stereoscopic view. So this must be a completely different experience for the host.
Yes.
Isn't it?
Yes, it is.
Great.
Yes, it is, because the difference is that you don't have an audience, and you have to talk to the persons, and not. It's less presenting. It's more like talking. I have to imagine that the person who is wearing the virtual reality glasses is next to me, so like you, and this makes difference. And sometimes that was also the problem when we did the first prototype of VR Rocks, a short magazine about virtual reality in the virtual world. It took, I don't know, I think about 2 hours, something like that, till Toby was teaching me it kind of 2 hours till I find a way to talk and not to present.
that's the great thing. Yeah, you have to have all these competencies in one set. You need the software guys, the hardware guys, the cameraman, the evangelist, the host, and everybody has to be open for the new for the new way of production or for the new experience. Yeah, I don't want to say shot, because it's not a shot anymore. It's really an experience. And but let's go back to Volker and Peter. You wanted to use the last 5 minutes or so to talk a little bit about the workflow and the efficiency.
Yeah, so to come really back to this real-time output, for example, this is a typical setup for some live streaming, where we have indeed, you can select the NVENC node for this real-time encoding, based in this case on the NVIDIA NVENC encoding hardware. And depending on what you want to do, as I say, there's also possibility for a feedback channel that, for example, that you not only have a broadcasting live stream, but also a personalized live stream where people can also interact with the virtual scene if you want it. There are different setups possible with different nodes here. As the Muxa, for example, is combining different channels together, like the video streaming channel in a control channel, which can be used by a client application, whether it's a mobile application or PC-based application. There are possibilities. Also some additional technical things, also what we didn't do it here, but also to mention some various options, as briefly mentioned by Klaus, when you can think of options, you can use motion capture for controlling virtual characters. We briefly used some joystick to control a car. Also basically you can use all the features of a typical game engine also for your movie production. What you also maybe can briefly show, which is often for other kind of applications useful, this 3D, 2D video animation thing. Also often the setup, also as integrated here, maybe we can also disable the 60 mode again. But also for some from other projects that you can, of course, fade in, fade out things. In this case, as can you change maybe the video or so? Put different videos in it, and that the typical format would be also about some talk show or whatever, where you can, like in a virtual studio in broadcasting, integrate various other elements like animations, videos, and this kind of things. This is one option. Some other option, in this case, we are using a real 3D scene with real 3D objects. Often it's also quite useful to just use pre-rendered panorama images. Especially if you want to keep it in sync with other applications, whether it's a real-time application or some other pre-rendered content. Also, for example, maybe you can disable the sky and do some panorama. And the panorama can be either a monoscopic image or video, or a stereoscopic image or video, depending what you have. In this case, you cannot see it here, but you would see it if you would look into the Oculus. It's a stereoscopic panorama image. Obviously makes it, also avoids that you have to get or model 3D objects. This is also one option. Also a lot of different possibilities depending on what you want to do. And for a little bit also more of the technical things, you already have seen here on the left side the tree control of the application. This is basically where all the elements in the scene are located, but there are also some nice tricks possible how you organize your scene. Because, also, for example, what we also had in this project Thomas mentioned before, there were various different, also for different variations of the scene, we had different camera positions, different elements in the scene, kind of things, and they can be nicely organized in folders, which you can basically use everywhere. Therefore, there is no predefined structure how the elements are organized in the setup here, but instead you can organize it basically as you want. For example, if you maybe scroll up, Peter, there was this include node here. For example, here all the stuff is a setup for the video in is linked to the virtual camera. But then, since you want to have different locations to it, we have here, if you click on the include node here, this is including now, is this the right one anyway? I think so, right? Oh, yeah, this is referring to the folders down below here. So for above, we had the basic setup, but here we now have much easier accessible all the different setups for the different positions, the camera positions and panoramas and kind of things. So you have it in one place, and you're not forced to have everything within the more complex setup of the basic setup of the whole scene in this particular case. So in the basic elements are, so you can define folders at use, you can use this include nodes to arrange the folder structure basically as you want, so it can be quite useful. And also to make a very quick outlook, which is also useful for more advanced projects. Also this project from Thomas mentioned was a good sample, so you can use scripting to control the editor. Also everything you can do in the editor you can also access via scripting. Also for example, let's select what we thought about showing. Also for example now, the vehicle, the Humphrey here, and you can of course here set the transformation of the vehicle, but you can also access all the properties here live. Also for example here this is as in this case a Python shell. And we now, also this is, maybe if you, properties maybe for example first here. If you go to the properties, so for example now here we have the different properties in the same as in the GUI element, like the transformation, post-transformation for example here. And then dot, for example let's change the x coordinate, add 1 to it or something like this. And since it's a full Python shell, you can everything you want. You can also load your custom scripts. Also, for example, it's an sample which we have used for this mentioned project. Maybe open it here. And this is a typical hacked, real-world, dirty script for quickly modifying the scene to enable the different settings, which camera position you want to have and which element you want to have. For example, as you can see here, maybe you can select this a little bit here. Exactly the commands we had before here, also to select particular elements in the editor, enable it, disable it, change parameters, something like this. For example, this script was then effectively used to afterwards batch render offline so 50 or something like this different short clips with different settings, which were coming from an Excel sheet containing all the different parameters for each individual setup, for example. And this is just on Python script accessing exactly the same Python commands as we have seen here in the shell. This can be especially quite useful for larger projects where workflow is obviously important. But I think so. These are the core parts.
And it's a really powerful and mighty software. Where's your background? Usually your software does live inserts for broadcasters.
Yeah, also we have a longer history for broadcasting software. Also it's used in, for example, German primetime news and ProSieben, for example, are using our software for a longer time now. Also this is also where we have the background of virtual production from broadcasting. Also a longer history in the game industry. Also Shark has been used for various games, and this is also a nice advantage to use all the game engine features also for virtual production. And also doing various things in the movie industry, where we maybe can quickly show here the tracks controls, which is different from our game engine. We also have a timeline for acting, playing actions in the scene and record everything, have all the different actions in the scene recorded in different tracks where you can replay it, manipulate and that kind of things. So basically combining the gaming world with the movie world, which is exactly also useful for virtual production here, like we are.
And which is a dream for every creative producer. It's great. So, and now we're...
Yeah, I think we are so...
And now it's, that is our demonstration part. Thank you very much, and we are giving back to Barbara and your questions.
Hang on there. I'm not taking the screen back yet because I like what I'm seeing. I don't have any question yet, but I'm prompting everyone to type them in if they do. I think Klaus did a great job addressing all the questions, for instance, about proportion, scales, and perspective. I think that was great. Those were all my questions. And also another question I had was like, okay, who's using it right now? And for instance, in your network, AFK TV, do you employ, the Shark 3D software for programs and broadcast?
The last time we used it was for the Bavarian Ministry of Economics, and we did a showcase together with DEXPERIO Thomas, who was talking at the... hello, this is Thomas.
Hi, Thomas.
And we used it for a showcase where citizens could visit two virtual worlds. One world in which was shown the way of the the German beer, obviously, in Bavaria. Yeah, so we had a beer brewing, crafting simulator where you could do your own kind of beer, and we had the head of the Bavarian Beer Foundation or something like that here, who was explaining which kind of witchcraft you need to use. Yeah, and the other one was somebody from the Ministry of Economics to explain the advantages of wind power, and we also had some simulations for the wind energy. And this was shown in the ministry, and this was a great success. I think we had over 4,000 visitors in the kind of day of the open door event where it was shown, and it was a lot of effort and a lot of energy we had to put into the project, because it was like it came out of nowhere and was and it needed to be done in like 10 days. Yeah.
Wow.
But it was a great success. Yeah, and Sharks 3D made it possible.
Wow, real cutting edge. Wow, you need a beer ministry, if I can suggest. But yeah, no, that's incredible, because I think we've come a long way from, remember Mary Poppins, where there was animation with the interacting with the actors. I mean, this is really groundbreaking. I think, wow, we really have, this. I'm really excited, and I hope many executives in Hollywood will take note and start creating new scenery and new projects with this kind of software. That's where we're all wishing. And we have one question actually. How does this fit into a film pipeline? For example, getting changes of the car back into Maya or Motion Builder. Maybe Volker can
I give it back to Volker. Yeah.
Yes.
Yes, indeed, this is indeed a very interesting question. We also had invested a lot of both thoughts and work into this. Indeed, one thing is to get it back, as it depends exactly on what you want to do, but we did a lot of research regarding indeed importing the animations, for example, in Maya. As for example here, quickly mentioned here, if you, for example, do all the movements in the real-time virtual world and record it here with this track control, which you didn't show, then you have first all the movements stored in these tracks in Sharks 3D. But then if you want, and this is where we did some research into, since information is available in tracks, you export it, for example, via FBX or something like this back in Maya. Depending, this is indeed one option. The other option is that you can also offline render something here in quasi real time afterwards with different rendering settings, more advanced lighting and shadowing settings, for example, to avoid going back. One note, which is our experience from movie production projects, is that you should be very careful what exactly you are getting back to avoid that you change the same things in different locations. And it turned, for example, out that meshes should be always go only from Max or Maya into the real-time software in Sharks 3D. Vice versa, it makes sense to get positions and animations back from Sharks 3D, for example, into Maya, but it doesn't make sense to get meshes back, something like this. Yeah. And also regarding animations, for example, it works best if you have an animated character, something like this, so that you basically export the own animations but not the mesh back into Maya, so that basically from Maya perspective it is like motion capture data, just not from a real live motion capture hardware, but in this case from Shark 3D, for example. Yeah? And there are different options, but these are options which at the end work best. Yeah? Yeah, hopefully I think these are the core parts. And some other maybe note about workflow integration is also, which also makes a lot of sense, to integrate it completely into the asset management pipeline, that all the recordings, all the videos and so automatically put into the asset management system, for example, Shotgun, something like this, where also Sharks 3D has the APIs for such kind of integrations.
Great. Thank you, Volker. We have another question. Would Shark 3D be able to support full presence of a character in the studio, typically using camera tech from companies like 8i or the like?
Yes, yeah. So in short, in principle, yes. We also experiment with such kind of things, whether it's also simple versions or, for example, also Kinect. Also, we don't promote it so much at the moment, also because of quality issues somehow. So in principle, yes, and depends what you want to do. Also Shark 3D itself is agnostic to it. Also obviously the philosophy is to integrate as much hardware inputs and output as possible. This is definitely one interesting hardware input. It's the end a matter of quality, and so yeah, also with especially also by simple chroma keying, as you know, the borders are a crucial issue. That is not just on stenciling, but you have basically anti-aliasing for the borders of a chroma keying, and this also which gets harder and the quality gets more problematic for depth cameras. Yeah? So it's definitely coming, and our philosophy is always to support everything which is available. Let's see how fast it is viable for good quality productions. Yeah? But it's also one area, if somebody has a special interest, what he wants to do, we are always very open to make pilot projects or something like this, especially for particular new hardware available also.
Thanks so much. That's great news. Okay, that was all the question. I want to thank you so much, Aline, for standing up for an hour for us and being... yes, and also thank you so much. You were very entertaining. This was a great show. I'm sorry I have to take the screen back and show my non-interactive, non-moving slides. Apologies for that. But I want to thank everybody for attending our webinar today. And I also want to remind everyone to visit our page at novedge.com, where you can find Shark 3D Live. There you go. I mean, I know it's not a small purchase, but wow, the potential. So for information on the latest specials and new release, also visit our blog and our Facebook page. Search for Novedge, and don't forget the next week's webinar is about designing context with Vectorworks 2017 camera match tool. And hold on, I just oh sorry guys, if you're still there, I have another question. So if you don't mind, I would like to read it to you. Okay, regarding the keen and real-time compositing, how do you decide if the person in front or behind virtual assets? Do you have depth recognition in place?
Also, I'm still, genau. Also the simplest setup by, also no active depth recognition, but just placing in the right place. Also indeed, the standard setup is, let's say, stupid simple, but it works in most situations. Depending on the hardware, because normally you don't have the depth information. You cannot, also first, of course, use advanced hardware. As used, as I mentioned in the question before, if you have some depth camera, also light field camera, for example, there are more possibilities, but in this particular setup, really just by placing it correctly, basically as has been done also in virtual studio production for broadcasting for a long time. Yeah? So it's simple, but works in a lot of situations.
Okay. Yeah? Thank you so much for taking this last minute question, and thanks again for a real wonderful demo. We're very exciting to see what's going to happen in the future of TV and broadcast and real-time live VR. So thank you for making it happen. Goodbye, everyone.
Thank you very much. Bye-bye.
Bye. Ciao. Bye. Ciao.